Assalamu alaikum. My name is Mohammad Abdul Shihab. My ID is 2350751. Now I explain about my DLC assignment. This is my assignment. So this assignment is about a automatic cloud management system. Here is some condition. Each passenger ticket card has RFID sensor that detects entry. If more than 3 passengers cross the yellow line simultaneously, an alarm should trigger. A synchronous counter keeps track of the number of people inside the platform. In a day, maximum of 20 tickets is issued. A 555 timer is used to generate the clock for both counter and alarm. An FSM is used to control the gates ideal, they check, then open and then close. The platform monitoring system sends the current passenger count to the control room in analog form via DAC, while the ADC is used to read sensor input. And my first question is sketch and sketch the block diagram of the system showing RFID sensors, ADC, synchronous counter, FSM, DSC and alarm. It means the RFID sensor, ADC, synchronous counter. This component, used and make a block diagram. I make a block diagram here. First of all, RFID sensor, then go ADC, analog to digital converter. It work when sensor detail when sensor detect. Then go to FSM, their ideal check open and close system. Then FSM2 make two paths. One path is synchronous counter to DSC to control room, and another path is alarm unit. If three passengers cross yellow line, then alarm buzzers will be buzzers. It's work to counter with a component called 555 timer. That's it. Then my second question is demonstrate how the FSM transition between ideal, check, open and close state depending on counter values. The FSM transition from open to close after 20 tickets are issued, and also show Verilog HDL code. So this is my transition from first of all ideal to check. When RFID sensor detect, then check to open. If the counter less than 10 and total tickets less than 20, uh, check to close. If the counter greater than or equal 10 or total tickets equal 20, then open to close. If a passenger in after a passenger enter, if the total tickets reach 20, directly goes to close state, then close to ideal. When the counter value returns to a safe range. Now this is my state chart, and this is my state table. State table where mm, I mainly open and close, check and open. Mainly outputs ideal, check, open and close. So this is my FSM is 2 bit, so I take 00 as ideal, 01 is check, 10 is open, and 11 is close. There is a reset button, I assume, and um, there is a go bar, that is that means 0, and if I go 1, then it's I run from ideal state to check state. So here is my state table. Here first of all 1, reset is 1. That means parent state go and state down, and next state and output all is present state and go. I don't know, but next state is 0. So next state when the reset pin is 0, next state is my present state. Now present state 0, go 0, present state 0 0, next state 0 0, then all is 0. If go is 1, next state then 0 1, it means then ideal to uh, go check. So ideal is 1, check, open, close, all is 0, then 0 1 to 1 0. 0 it means check, then check to open, check to open, check is 1, then open to check, open to close, open is 1, then open to ideal, close to ideal, close is 1. Then here is another arrow from check to close according to my conditions. So then again my next state is 0 0, it comes my present state 0, ideal to check, check to close, and close to ideal. Then I make this is my equation for Verilog HDL code. Here n naught in extension 0 from right side, n0 n1, and present state from right side p0 p1. When I choose n0, there is in the row I see there is one, which column is I see 1, and I choose this column present state, and I make the equation for n1 same as n naught. Then I choose ideal, check, close, open, all things are same as n naught process. Then my final output is final equation is that n naught reset bar p1 bar plus p naught bar, n1 reset bar dot p naught, ideal p1 dot p1 dot p naught, p1 bar dot p naught bar, check p1 bar dot p naught, or open p1 dot p naught bar. and close p1.p node. Then I write HDL Verilog HDL code for my for this FSM system. Then this is my second question complete. Then I go for third question. Third question say that there is a condition that more than three passengers cross simultaneously. Show the simplified Boolean expression. Show using only NAND gates. Show how the logic control timer. So my condition, if three passenger, it means if three passengers cross your line simultaneously, then alarm should trigger. So I assume there is four passenger there to cross same line. So alarm should trigger when when alarm is on. It means A is on. If A equals 0, then alarm should be off. So when A equal 1, it means three passengers cross the yellow line. Now I make a Boolean expression with a logic circuit. I assume y for my output, y equal a dot a dot b dot c dot d. First of all, I take two input a and b, and then I add AND gate and my output AB, and CD. Uh, then I choose CD AND gate. Output is CD, and these two AND gate AB and CD I again connect with a AND gate, and my output is ABCD. Now I convert my AND gate to NAND gate. So where is my AND gate? I convert this AND gate with my NAND gate. So NAND gate rules is, if there is AND gate, one AND gate, it replace one NAND gate, and the output of NAND gate will two input with a NAND gate. Then I find my final output. So I make this. I replace the NAND gate with my AND gate using rules. Then I find my destination. And there is a question that show how the logic control timers. This logic is either show 1 or 0. If three person cross the line, then give me 1. It means alarm is beeping, or if don't cross, then 0. This logic uh, mainly control triple timer to generate pulse that drive the alarm. Mainly decided the timer in the timer should run or not. Then my fourth number question is triple five timer circuit. Show the triple five timer circuit for the alarm with frequency P5 Hz and duty cycle Q%. P equal M plus ET plus E plus T plus R plus O. Q equals 100 minus P. If P5 is not within 250 to 4500 Hz, set F equal 400 Hz. Select the most suitable capacitor. 50 microfarad, 250 microfarad or 4570 microfarad. There is a hint that if P equal to 20, then P5 equal to 205. This hint is used in frequency P5 Hz. So here is a option that instruction related to use variables. There is metro. This I replace with my ID 235075441. Here I 235075441. The middle digit 507541. It's by metro, so there is a 0. And my question say if 0 it's replaced x plus y plus z. So x is my ID number 2, y is my ID number 3, and z is my ID number 1. I addition these three things, then my result is 6. I replaced 0 with 6, and my metro number is 56754. Then I addition those numbers, and my output is my equation is 27. It means P5P is 27, then frequency is 275 Hz, and my equation is under 250 to 4500 Hz, and my duty cycle Q% 100 minus P, and P is my 27. I 100 minus 27 is equal 73. No, 73. Then I assume I take 50 microfarad for my equation, and I mainly get R1 and R2 value. So I use duty cycle equation. This is my duty cycle rule. R1 plus R2 divided by R1 plus 2R2 into 100%. And I find from my ID equation in my question, I find 73 duty cycle. So 73 equal R1 plus R2 divided by R1 plus 2 into 100. Percentage is gone. Because 70 here uh, Q equal to 100 minus P. Okay, Q duty cycle is Q%. So percentage is gone. Then in equal the left and right side division by 100, then I find 0.73 R1 plus 2R2 equal R1 plus R2. And my final result R1 is, here my equation, and my final result is R1 equal to 1.704 R2. Then I, in the T equals to time period means equal 1 by frequency. So I so my t value is 0.0036 second. Then I write equation of time period t equal to 0.693 C1 R1 plus 2 R2. Here I find R2 value, and I take the R2 value to R1, and I find the R1 value. So my R2 value is 28.05 ohm, and R1 is 47.8 ohm. And here is my 555 IC circuit. 555 IC circuit. Here I use two op-amp, A and B. This is plus, this is minus, and B plus minus. So here is a use 3 resistor. This resistor is 5 ohm, 5 kilo ohm. That is called, for this it is called 555 ohm. Here in the here is VCC. This is my power supply. So A is connected, A plus, so open A plus and B minus connected in series, and A minus B plus is connected with the ohm in series. My op-amp is work if plus value is greater than minus value, then it output is 1, either 0. Then it go a multiplexer. Here is a switch R, Q and Q bar. Q bar is my output. Then Q bar is connected with a transistor, BJT transistor, and Q is output with go a NOT gate, and output always voltage show in minus. Then I go for my fifth number question. Show how the DAC, digital to analog converter output voltage represent the passenger count for 5 and 10 passenger. Here my question say, assume 4-bit digital to analog conversion and V reference equal 5 volt. So I make equation and find the value for 5 passengers and 10 passengers. I find this from my question, and for bit DSC will say 2 to the power n minus 1 equal 15. 15 bit. 15 4 bit means 15 byte. So for each step means 0 to 1, 1 to 2, 2 to 3, 3 to 4. Each step I need 5 by 15 equals 0.33 volt per count. Now for 5 passenger counter, my value is 5 because 5 passenger, so my V out equal 5 divided by 15 into 5. V reference divided by 4 bit DSC into 5 equals 1.67 volt, and my for 10 passenger my V out is 3.33 volt. This is my question, and my last question: illustrate limitation of this developed metro safety system. My last question say illustrate limitations. If I made a metro safety system with this automatic cloud management system, what types of fault or error is showing? I try to find some errors that the RFID sensor might miss it or miss some passenger, causing wrong counts. If passenger is more than 20, then it will gone. It will happen. Then a very loud alarm might scare people and cause panic. If my system is made for very low people, for 10 people or 20 people, if the system goes a big system, then it may disturbed. All component work not properly, then 555 timer or counters, if it stops, then whole systems not working. There is a very big error that 20 ticket fixed logic cannot handle larger crowds without changes, and FSM for state may not handle the real world scenarios. No backup system for circuit operations. I find those types of some errors in this automatic cloud management system. And that's it. All my question answer is this. Thank you so much. Assalamu alaikum.